Hi, this is Harish here. Welcome to DB2 LUW Tips and Tricks video tutorial part 134. In this tutorial, the topic that I'm going to discuss is LSN, the log sequence number, a quantum object or quantum entity. It's just a fun topic. I'm just putting it in an interesting way so that people will click on the video and watch it further. The scripts that I'm using are available for free download. The data files are available for free download at db2lewacademy.blogspot.in. Please subscribe to my YouTube channel, youtube.com/db2lewacademy. This is a disclaimer. I have no affiliation or association with IBM, so I do not have any access to internal documentation. Whatever I am saying here in this video is a speculation based on my test cases. It gives more of my understanding of things, how the LSN works and things like that. Definitely verification and confirmation is needed, and from experts, and validation is also needed. And even if experts or happen to watch this video, please share your comments and inputs. That will be really helpful for my understanding as well. This is the problem scenario. So here I'm going to show you an analogy between the log sequence number and a quantum object or a quantum entity. So what is a simple quantum entity that we can think of? That is the light. And in the 1900s, 1920s, around 1920s, 30s, there was a revolution, or in the scientific community, there was a raging fire. And this was like foundation principles of quantum mechanics. That is called as wave particle duality of light. So we see that light is during various experiments, light exhibited the property of a particle nature in certain experiments, and it was also exhibiting properties or behaving as though it is a wave. So it was behaving as both wave and a particle in different scenarios. The experiments, the kind of experiments they did, it was not consistent. So in some people were saying, okay, it's behaving like wave, and some people were saying no, it's a particle. There was like a lot of debate, and the whole thing came up with the idea of quantum mechanics, quantum field theory, and blah 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 blah. Okay, so I'm not a scientist here, so I'm not a physicist or scientist, but what is the analogy that I'm trying to propose here is, when you define LSN, so does LSN represent the number of log records generated, or does the LSN is a measure of space? I don't mean the universe space or quantum space, I mean the transactional log space. So is LSN a measure of transactional log space and not the number of log records? So it should be either one of that, right? It cannot, in certain activities or when certain tasks are performed on the database, the LSN behaves like a measure of space, and when certain activities are done on the database, it works as like number of log records. The LSN number represents number of log records. It cannot like do both the things, right? That is the duality of LSN. So dual behavior of LSN. So that's why I call it as a quantum entity. So I'm not sure whether that's a good analogy, but it's just for fun. Okay, usually the LSN range is like from 0x0000 to FFF in the later versions. Okay, and this gives like 18 exabytes of space. So whenever I kind of ask questions about LSN in the forum, I get a response like, see, you have 18 exabytes of LSN available to you. So definitely, if it is a measure of transactional log space, that much of insert, that much of delete is not going to happen over a period of even 5 years. So your database might be only like maybe 1 terabyte or 2 terabyte, but the changes is what is contributing to the LSN. So for example, it could be insert record, it could be update, delete, load, in place rearg, and just imagine that with in place rearg, like in a HADR system, log index build will be on, right? That's like a recommended suggestion, right? So it is going to generate huge number of log records, and I do see certain situations where people switch over to infinite logging to build some big index, like some table has to be done a rearg, and 5 indexes are getting rebuilt, and it's shooting out the transactional log space, so they want to switch over to infinite logging, and with log index build on, and this will generate so much of log records. So whether LSN, if we define it as per number of log records, or even if it is a measure of space, either ways, all these kind of activities, even frequent deactivation and activation, online backup, because at the end of the online backup the active log file will be closed, and so there will be some little loss of LSNs over there. So it's the volume of changes, that logged changes, that is significant. The transactions, the transactions that are creating the logged changes, that is what is taken into consideration. So it's not just, see, your DDL is not going to frequently change, and DML, see, you always have the load utility instead of doing inserts or updates, right? So it might be a lot of best practices to do. So unless you follow unless you follow the best practices, if you are following the best practices, you won't be exhausting these LSNs. But not only these DDLs and DMLs, but the maintenance activities like create index, drop index, like these in place reargs, these can also contribute, particularly with the log index build on, it can bring about more consumption of LSN, right? So it's just a thing to keep in mind. And IBM developers or engineers or forums, wherever I go, they are saying like, we have never seen any database exceeding this much. And in earlier versions, 9.1, 9.5, this was a 6-bit or 8-bit placeholder, which was represented as a hexadecimal digit. So what happens is, it was only in the order of terabytes, but then the LSN range got extended to 16 bits in the later version. Like I think in 10.1 itself that change is there. I am observing, I'm using now 11.1. It is there, and they have expanded to 16-bit. So it's going to give 18 exabytes. Earlier it was in the order of terabytes, now it is exabytes. So very there is very low possibility or no probability or possibility of exhausting this LSN. You should be insanely doing something. That's what I'm hearing. But that's all. But this kind of thinking will just help us. It's not going to help us in a day-to-day activity, but monitoring your LSNs is also a best practice, I guess. And this is the version difference that I'm talking about. And in 9.7 and between 11.1, there are significant differences, and I'll show you that in the image itself. Probably this is more, this picture is more, the fonts are more clear. Okay, this is a scenario. So what I'm doing is, in version 9.7 fixpack 11, I'm importing 15,000 records of 1 byte. So you can just create a table with only char of 1, right? So, and you can just insert x into that. So you can create a del file x like 15,000 lines, So so after that I'm importing that. So before issuing the import utility, I run the db2 pd-db logs, and it will display the current LSN value. So that is before the import utility is run, and after also I capture the before and after data, and this minus this is the hexadecimal range. So that is the LSNs that I am consuming, that many number of LSNs I am consuming. And you can see that for 15,000 records it is consuming 816,000, I don't know, so close to 1 MB we can say. Okay, and this is like transactional log space. You can just use the monitor switch UOW on and get this information. So I have done 3, like repeating the test to take an average and see, and I am also increasing the record size from 15,000 to 30,000. So when I do that and generate this information, this is somewhat very closer to the transactional log space. So 3 MB, 1.6 MB, 1.5 MB, it's almost half of it, but at least it represents it doesn't represent the number of log records for sure, and it is at least a factor of transactional log space. Maybe it is showing only half of the amount than this, because log space is inclusive of compensation log records. Maybe it is because of that. I'm just guessing, but definitely it's not number of log records. So it is a measure of space in 9.7 fixpack 11, and the same can be corroborated when I'm importing one record of 1 MB or one record of 2 MB with a blob object. So even I did the same thing, and you can see that the transactional log space is 1 MB, 1 MB of data, 2 MB, 2 MB, And you can see the LSN range consumed is exactly 1 MB and 2 MB. So this tells us very clearly it is a measure of space in 9.7. Measure of LSN is a measure of space in 9.7 fixed pack 11. But in 11.1, I think in 10.1 and above, they have changed this to reflect the number of log records. Look at this. If I import 15,000, it is exactly 15,000 LSN range. I mean, plus or minus, right? 15,000, 54, 15,000, 15,000. And if I import 30,000, and I have imported even about 200,000 records, and it is consuming 200,000 LSN. So what they have done in 11.1 is they have split the LSN into two things. See, here it was only one representation with only this measure of space, whereas here they have switched into two things. One is the LSN, another one is LSO. LSO is more like the byte offset. So this will, LSO range will match with your transactional log space. So again you can see here for 1 MB of transactional log space, 1 MB of LSO range, 1 MB of transactional log space, 1 MB, 2 MB of transactional log space, 2 MB of LSO range, and 4 MB of transactional log space, 2 MB of LSO range. You know, the same proportion, half of it, right? We saw here also, if it is 3 MB here, it is 1.6 MB. Same concept comes to LSO. So the space measure is more taken care by the LSO, and LSN range is just a representation, hexadecimal number, like a counter kind of a thing. It doesn't carry that much significant about the space. Since it is a counter, it is reflecting the number of log records. You can see that, and I tried it in insert query also, like just straight away insert into values, right? Insert into table name values. I tried that, and it is exactly one commit log record will take one LSN, one insert log record will take one LSN. It's pretty consistent. But now here is the duality I'm saying. So if it is representing the number of log records, when I'm importing only one log record, like one record of 1 MB blob object, it is taking 65 LSNs on an average. And if I double it, like a one record with 2 MB, you can see it is taking 128 LSNs. I don't know the logic behind this. So whether one insert of blob record, the blob data is split internally into different SQLs, I don't know. So I don't know the internal thing, how the blob records are inserted. Actually, it's how it is happening internally, because the consumption of LSN is not reflecting the number of log records. See, here it is inserting pretty consistent with the number of log records, but here it is not consistent with the number of log records. This is the quantum behavior that I am saying. See, here it is consistent and it is a measure of space in all the scenarios, whereas here it reflects number of log records, but it reflects the number of log records for the import and insert SQLs like that. Obviously I need to check for update, I need to check for delete, a lot of other things, how things behave. Further test cases are required, but still I am saying definitely this LSN range doesn't look good, right? Or for the blob is kind of, blob objects are specifically handled such that the LSN they consume is very less. But the byte offset, if you take the LSO, it is 1 MB only. It reflects the size correctly, but in terms of LSN, it is far less. I mean, it is far more actually. You should only consume one record, right? So maybe 2 LSNs, including the commit, but it is taking 60 LSNs. I don't know why. 60, I mean the hexadecimal 60, decimal 60, hexadecimal 40. So I'm not sure, sorry about that. So that's the thing. So obviously this tip or this session, this is not like I'm saying this is the solution, this is the problem, this is how it works. It is just a thought experiment. It is, and it's not even a thought experiment, it's just my kind of test cases that I do to enhance the learning of the LSN. And it's not something that you daily use, but it's definitely a best practice to track your LSNs, make sure that you are not consuming too much of LSNs, because you need to change your transactions. Use import instead of import. You can probably think of using load if there are unnecessary consumptions of LSN, and better ways of creating the index, reorganizing the index, what best you can do in order to minimize the LSN consumption. I don't know. So people are saying, I mean, all the forums I have heard the suggestions from experts that It's an insane limit, 18 exabytes you will never reach, don't worry about it. So but I'm just saying, let's just be, it will be it will give a good understanding. We'll feel, I'll just feel okay, yeah, I did learn today something new. It's just for that feeling. So please share your inputs, please share your comments, please share your comments in the YouTube page. And this is the file that I use, test case file. So here you can see I've created a blob data with logged thing in a recoverable database, obviously. And this is what I do. I use the db2pd logs command, and this is the typical import command that I use. So these are all very simple test cases, so I'm not going to demonstrate this how I did it like that. And the page size also doesn't matter. I tried it even on 8K and 16K page sizes. It's the chart, the diagram that I showed is pretty much consistent. That's it. So see you in the next video tutorial. Until then, bye bye. Oops, what happened? Okay. Okay, sorry about that. How do I stop the recording now? Minus. Man, Windows. Okay. Okay, there you go. Okay, it still didn't stop.